Hi, I'm Bob Tabor with www.learnvisualstudio.net. In this module, we'll talk about DocumentDB. DocumentDB is Microsoft's new NoSQL document database in the sky. It allows you to store schemaless JSON documents and then retrieve them really easily, and we'll talk about some of the features and benefits. JSON, JavaScript object notation, we'll talk about why that's important in the very next slide. But it is schemaless, so it's unlike what you've used in relational database management systems where up front you had to decide on the structure before you could begin developing your application, essentially. With a schemaless style data store, you can change and evolve your object model and then have that persisted down to the document DB. And if two documents have a different set of properties, that's not a problem as far as the database is concerned. We'll talk about that more in just a moment. But if you're familiar with relational database management systems, stored procedures, triggers, and user-defined functions are a core staple of the programmability of that particular database management system. DocumentDB is unique from some of the other Azure offerings like Azure Table Storage in so much that it gives you some of that same functionality built in really close to the storage mechanism itself. Not only that, but you can write the stored procedures and triggers and UDFs in JavaScript as opposed to some SQL syntax. One of the things that DocumentDB does really well is that it allows you to index not just the primary key. Like in Azure Table Storage, you really only get two indexes. You get the partition key and the row key. But in DocumentDB, not only can you search for things by the essentially the ID, but you can also search and do some rich querying on all of the attributes of a given JSON document. We'll see how that plays out in upcoming modules and slides. DocumentDB is much more elastic than a relational database management system in so much that you can grow it to incredible sizes. Like, for example, Microsoft OneNote is using DocumentDB under the hood, and it stores, I think, petabytes of information across all of its users. And then you can also tweak just about everything in DocumentDB, which makes it a little bit unique from some of the other storage offerings like Azure Table Storage and so on. So we'll talk about in a moment the different the trade-offs between performance and consistency, but you can definitely tweak that. You can tweak how you want the index to be set up and how you want it to perform. You can tweak security on a per user basis for individual collections of documents and so on. And then also from an accessibility standpoint or programmer's standpoint, you can access it via RESTful HTTP API, which is kind of the foundation for all the other client libraries. Like there's a Node.js client library, a Java client library, and obviously a .NET client library, which is the one that we'll feature in this series. So going back to the notion of JSON documents, why would you store your data in JSON as opposed to, let's say, XML or some comma delimited format or whatever the case might be? Well, I don't know if I can answer this completely, but JSON can represent some complex relationships between objects. So in a relational database management system, you can have relationships between tables. But in JSON, you kind of represent that same thing as containment relationships. So in other words, a family has parents, it has children, it has pets, right? Whereas those might be in separate tables in a relational database management system. But you can also be self-referential as well. So that's something that was always a little bit difficult to describe in a relational database management system. So for example, a single product might be made up of multiple products that might be in turn made up of multiple products. Well, representing each of those individually and then each of those as a collective was always a little bit difficult in a relational database management system. But since JSON is kind of structureless, you can represent those things fairly easily. It's also schemaless, and that might seem, kind of like a problem if you come from my background, which is I want everything very static. I want everything known up front. It's actually very liberating in so much that you can grow your requirements over time. And so, for example, your POCO objects, you can add new ones, you can add properties, you can remove properties, and as those get dehydrated, as those get serialized down and stored in your DocumentDB, it's not a problem that one document doesn't have the same properties or objects as another document inside of that same collection. So in other words, you don't have to know the structure up front, and in relational database management systems, you had to design your data model and then start building your application. But with the schemaless database, you can really just start building your application, and you don't have to worry about persistence. It'll take care of itself. Whatever you come up with your object model, you can just say, okay, I want to store that now, and I want to store this now. I'm going to add some properties, I'm going to store that now. So it's a very different mentality when you're building applications. And then also, why would you choose like JSON documents, for example? Well, it's the native notation, obviously, for JavaScript. And since the web is built on JavaScript, and you're going to, through things like AngularJS, communicate between the client and the server, it makes sense to just be able to project out a JSON document from a SQL query and then pass that directly to the client and let it, on the client, through JavaScript or whatever framework that it's using, decide how it's going to render that to the end user. Okay, I thought it was useful, this diagram that I pulled off of the DocumentDB, documentation. I thought it was useful to see kind of the taxonomy or the hierarchy of items here. First of all, at the very left-hand side, you can see that there's an account, and we'll create an account in the very next module. It's very easy to do, but you'll do it through the portal. A single account can have multiple databases, and a database is pretty much comprised of collections of data and users. What are collections? Well, collections are a combination of actual JSON documents as well as some of those programmatic features like stored procedures, triggers, and user-defined functions. Collections can also have attachments, so any kind of file, an image, things of that nature. Although that will make your DocumentDB collections a lot larger than you might want. Let's dive into this notion of what a collection really is. I said here that a collection is basically a container for documents as well as some of the programmatic features, but it's several different things. It's a container of JSON documents and the associated JavaScript application logic, like I just said. JSON documents inside of a collection can vary dramatically, and this is kind of something that's difficult. If you're coming from a relational database management system background, you might say, okay, well, it sounds to me like a collection is like a table. No, it's nothing like a table. Don't make that association whatsoever. A table has a structure, whereas a collection has no structure. It's just a place where you can put stuff, put documents. You can put a document that represents a truck, and a document that represents a person, and a document that represents a dog, and all of its hierarchical containment objects, child objects inside of it. All those can be lumped into the same collection. When you query the collection, you'll only get the documents that you're looking for, so you don't have to worry about getting a lot of extra superfluous stuff. It's a change in mindset again from the relational database management system. A collection is also a unit of scale for transaction and query throughput. So we'll talk about this a little bit more in a moment, but basically you're purchasing capacity units. I think one capacity unit currently during the beta is basically 78 cents a day, and a capacity unit represents a certain amount of data that you can store as well as a certain amount of throughput, so the number of transactions per second that you're allowed. So if you want to purchase 2 capacity units, about $1.50 a day or $1.60, then it would double the amount of transactions across all of your collections for that given database. And then also it's a unit of scale for capacity. And I'm not going to go into talking about how to scale out using DocumentDB. There's a great document that talks about your different options. Take a look at the URL there on the slide, DocumentDB-sharding. But there are different ways that you can partition your data such that you can grow your data to terabytes across many different collections or many different databases depending what your needs are. And then also collection is a unit of replication. And we'll talk about replication and the important role that it plays in DocumentDB. That's a little bit different than replication that we've seen up to this point, for example, in Azure SQL Database. So let's go ahead and talk about performance, and that will lead us to that conversation about replication. So data is saved on very quick physical devices. So there are no mechanical parts. SSD hard drives, if you're not familiar with those, are extremely fast. That's what you have in the fastest gaming laptops and gaming computers, and then also high performance servers. And so this is where things start to get interesting as well. In order to increase performance, not only did they choose higher quality hardware than maybe some other storage options, but also rights to the there are several different replicated versions of your collection. So there are, for example, at least one primary and two secondary replicas of your collections. So every document you stick in a collection, it gets written to other places automatically. And so these replicas are spread on different hardware within the same region in order to protect it against failures. That's definitely one benefit you get from it, but it goes so much deeper than that. Not only are you then writing to ensure that you're not going to lose any data and by putting it on different hardware, but you're also doing that to increase your read and querying speed. So all the writes happen against a primary, and those get replicated to the secondaries, but any reads that come in or queries against your collections will be distributed across those three copies. Now this will bring up some interesting situations about when and how this will actually take place, and you get to tweak that based on the needs of your application. So let's briefly talk about pricing. Obviously, you'll want to take a look at Azure's own website for this, but essentially you're priced in terms of capacity units. And a capacity unit really dictates two things: the amount of data that you can store, and then also the throughput, the amount of transactions, queries, inserts, whatever you want to call them, per second. So, for example, a single capacity unit will give you 2,000 requests per second, and so it represents one request unit. Now those requests will be spread across, so a single capacity unit will service all of your collections. So that might be another reason to partition into different accounts or into different databases. So in other words, if you have two collections that are running and you bought one capacity unit, you'll get 1,000 requests per second for each of those collections. Okay, so that might affect how you set up where you put your collections and which databases and so on. Also, this notion of a request, it's kind of a flexible idea. It's not just a single query. It really depends on the size of the document. So if you're wanting to insert 1,000 large JSON documents all in one shot, that might count for more than a single request. It might count for multiple requests that are being metered for a given second. So some things here are a little bit different than the way that other services are priced on Azure, but essentially at a high level it's the same. It's the amount of capacity and throughput that you expect to use. And so that pretty much wraps up a good introduction, but there's a lot more that we're going to say about the specifics of DocumentDB. We're going to look in the very next module at common tasks, show you some great code examples where you can learn about how to create databases, collections, documents, upload documents, query those documents, and so on. Then we're going to dive deeper into this notion of consistency and talk about that. So if in the replication scenario you are writing to one database, or rather one data store, and it's replicating to other data stores inside of the same region, there's going to be a lag time between those writes. So when other people are reading, are they getting dirty information or are they getting clean information? Well, you get to decide that, and we'll talk about that consistency versus performance trade-off in an upcoming module. Then we'll talk about SQL querying. We didn't really mention much about this, but you basically can query your DocumentDB using a SQL-like syntax. And there are some cool tools that'll help you become more familiar with how to do this, because there are some nuances. I mean, when you use a structured query language, you're working against structured data, but how about when you're working with schemaless data? Some small changes, but the great news is that by using a SQL syntax, you're essentially getting to repurpose your existing TransAct SQL skills. And then finally, we'll talk about programmability. That would be, creating stored procedures, user-defined functions and triggers using JavaScript. Okay, so then that should round out your knowledge, and then you can dive deeper after that and as more information comes available about DocumentDB. All right, so let's pick it up in the next module with some common tasks. We'll see you there. Thank you.